Alright, my beloved grade 9s, we are going to actually do a live lesson, unplanned, unstructured.
I am your new host for the Maths game lesson. So those who are joining in who are grade 9, I hope you guys will appreciate. It's just that the actual host of the lesson is not here, and so has asked me to be able to actually take over marching orders. So I hope that even though it will be a different person, but that you guys will be able to learn and engage quite a bit from the lesson. So we'll be looking at questions. Alright, just a second. Okay, here we have it on the screen. I'm sure you can see the activity that we'll be looking at, grade 9s. We are looking at transformation geometry, so we'll be answering these questions. We have I think 4 or 5 activities that we'll be looking at. We call these, or at least the host, when he usually runs these live lessons, he usually calls these game challenges. So hope you guys will be able to bear with me, being the one who's here today, and you will be able to learn a lot. So from this first activity, we are asked to translate the following points according to the rule in brackets and write down the new coordinates of the image. Plot the point and the image on a Cartesian plane. So if we look at the first question, this is grade 9, just me. If you look at the first question, A, 1 and 3, okay, we're looking at transformation geometry. The host of the platform did a video yesterday on transformation geometry, the introduction. So if you missed his lesson, you can actually go to his YouTube channel. On the YouTube channel, the link is in the bio. It's also, I think he also calls it MathsIsAGame. But today he has asked me to actually do the actual corrections of the activities that are attached to what he had taught you guys yesterday. So if you want to watch the full video of the things that he taught yesterday, you can go to his YouTube channel. You can watch, I think he did a video of close to 2 hours, a live lesson that basically covers the different concepts around transformation geometry. And then today he has asked me that I actually go over some questions with regards to it. So let's look at activity 1. The activity says translate the following points according to the rule in brackets and write down the new coordinates of the image. Plot the point and the image on a Cartesian plane. So if you're looking at number 1, it says point A, which is 1 and 3, and then it says 3 units to the left. So I've been asked to do the corrections with you guys. I believe he says that he also sent activities that are like this in the group, but just for the benefit of those who may not be able to attend the session now, then they'll have the chance to actually watch the video when it's posted on the YouTube channel. Okay, as I said, the host is not here, so has asked me to actually take over marching orders. All right, so translate the following points according to the rule in brackets and write down the new coordinates of the image, as you can see on your screen. Plot the point and the image on a Cartesian plane. So number 1, A1 and 3. If we are saying A1 and 3 moved 3 units to the left, what does that mean? What becomes the new image of A on the Cartesian plane? So if A is 1 and 3, the image of A translated 3 units to the left, what will be the new coordinates for A? Can you guys comment in the comment section and let me know what are the new coordinates of A? If, as number 1 says, 1 and 3 has been translated 3 units to the left, what are the new coordinates of A? Right, so first and foremost, if we're talking 3 units to the left, which coordinate is being affected? Is it X or is it Y? And then 2, if we're saying 3 units to the left, is the coordinate affected, are we going to add 3 units to it, or are we going to subtract 3 units from it? And then therefore, what is the new coordinate for A if A1 and 3 is translated 3 units to the left? This is grade 9. So can anybody in the comment section let me know what are the new coordinates for A? The image of A. Anyone? Anyone? Are we playing the silence game, guys? Is it because we are not used to me? Please, guys, don't be silent. I believe the host has told me that you guys are usually so active. Now, if you are silent because of the new person, then I guess this is a big mistake that the host made. Unfortunately, he cannot be here, so that's why I've been asked to take over live lesson. Okay. Anyone know what the new coordinates of A will be if A1 and 3 has been translated 3 units to the left? We're looking at activity 1, number 1. Okay, not any other one, but number 1. What will be the new coordinates, guys, of A? Okay, I see Smart Study commented there. Smart Study says, is it going to be -2 and 3? Do we agree, guys? -2 and 3? Will that be the new coordinates of A if we are shifting 3 units to the left? Do we have consensus amongst us? Or does someone disagree? Or do we all agree with what has been shared by Smart Study? Okay, so I'm just gonna move this a little bit, just that. So let's check this out. Okay, so in the document we are said we need to translate the following points according to the rule in brackets and write down the new coordinates of the image. Plot the point and the image on a Cartesian plane. So first and foremost, if we write down the point, okay, I'm just gonna move this a little bit. If we're saying A1 and 3, and we all agree that it's 3 units to the left. Remember, we said that translation, what does translation mean, guys? If we are translating, it means we are sliding either to the left or to the right, or we are sliding up and down. Translation does not change the size of a point, an object, or a line segment. So if we are saying point A1 and 3 is translated 3 units to the left, first question is, who is affected? Is it X or Y? If we are saying to the left, who is affected? Is it X or Y? So our first question needs to be answered, who is affected? Hopefully we understand that when we are talking about left or right movement, that means horizontal translation. And horizontal translation always affects which coordinate? It affects X. Okay, so I'm just trying to recap what we learned. So horizontal translation will affect our x-coordinate. Then if we are saying 3 units to the left, what does to the left mean as far as our x-coordinate is concerned? So that means 1, the x-coordinate 1 is going to be affected. But if we say 3 units to the left, it means that we are going to subtract 3 from who? From x. So this is very important to note. Subtract. Because to the left means we subtract. But if it had said to the right, it means that we would add. Okay, so what we need to understand is that horizontal translation, or to the left or to the right or left, we are always affecting x. All right, it affects x. But then if we are saying to the left, it means we subtract 3 from x. So our image of a would be 1, we subtract 3. But then of course our y-coordinate will stay the same. So the new coordinate of a, the image, will be 1 minus 3 is -2. And therefore the point a, the image of a, translated 3 units to the left from the original a coordinate will be -2 and 3. And we write this symbol to indicate that this is the new image of who? Of a, when it is what? Translated 3 units to the left. X is affected, and because it says to the left, we subtract 3 from who? From x. So therefore we get -2 and 3. Okay, then if we are to draw then or sketch this point on the Cartesian plane, -2 and 3, we can go there, guys. On the Cartesian plane, x that is -2, that is here. X that is -2 is everywhere on this vertical line. And then y that is +3 is everywhere on this horizontal line. So where do the two meet? They two meet exactly there. So this would be a, the image, which is -2 and 3. So this would be the image of a. Whereas a originally, which is 1 and 3. 1 for x, which is here on this vertical line, and 3 for y, which is there on this horizontal line. Where do the two meet? The two meet here. So a, the original, would be 1 and 3. That's where that would be located. Okay, let's move on to the next question. Okay, hopefully you guys can see that and we are clear about that one. So let's look at number 2. Okay, the next question, number 2. Translate the following point: -3 and 0, b, which is -3 and 0, 3 units to the left. So once again, b, which is -3 and 0, we are told to do what? To translate it 3 units to the left. So what would be the new image of b if it is translated 3 units to the left? So we ask ourselves those questions. If we are saying it's translated 3 units to the left, which coordinate is affected? Is it x or is it y? Then 2. How is it affected? Okay, so I'm sure we by now should be able to follow through as to what would be the new coordinates of b. If b is -3 and 0, and we are asked to write down the new coordinates of b, the image, okay, if it's b is translated 3 units to the left, what would be the new coordinates, guys? In the comment section, would you be kind enough to give me a response? What would be the new coordinates of b? Right, I see a lady there with a question mark in the profile picture. Okay, I see your answer there. It's just that I think my comments here are filtered, and so your answer does not appear, but I see it. I think it's Lesser has written -6 and 0. Manda Melvin has also written -6 and 0. Mbu is also saying -6 and 0. Okay, I think we have a general consensus there of -6 and 0. And so let's just review this and see if really it is true. So remember, we said B, which is what? -3 and 0. We want the what? The image of B. So what? How does the translation affect the coordinates? So if we are saying 3 units to the left, it means we are going to affect who? It is going to affect x, the x coordinate. So we are going to subtract 3 because we are saying 3 units to the left. We subtract from x. And then obviously the y coordinate stays the same. So that means our new x coordinate, -3 means -6. So that would be -6 and what? And 0. So we are 100% correct. Those who said -6 and 0, you guys are 100% spot on. So we can go to our Cartesian plane. Let's go and locate the point -3 and 0, the original. So -3 for x is here, and then 0 for y is on the x-axis. So that means we are located exactly here for -3 and 0. And then our image of B, which is -6 and 0. -6 is there, and obviously 0 is on the x-axis, so we are exactly here. So that's B, the image, -6 and 0. Okay, done. Let's go and look at the next question. Letter C. -2C, which is -2 and -2, if it's translated 5 units to the right. Translated 5 units to the right. What does translated 5 units to the right mean? So 5 units to the right. So we are still here moving horizontally, because left to right means horizontal translation. But then if we are saying to the right, okay, so horizontal translation will affect our x coordinate. Okay, so we are still going to be affecting the x coordinate. How? If we are saying 5 units to the right, what does 5 units to the right mean? Okay, so I'm going to give you some time. You guys can comment in the comment section. What would be the new coordinates of C if we are saying 5 units to the right? What would be the new coordinates of C, the image of C, if we are saying 5 units to the right? So like I said, to the right still means horizontal translation. But then if we are saying to the right, what does that mean? It means we are going to still affect our x coordinate. How? If we are saying 5 units to the right. So let us go ahead and actually write down the coordinate of C that we have. It's -2 and -2. 5 units to the right. 5 units to the right. So who is affected, guys? Who is affected? The question, who is affected? So we know that the coordinate that is going to be affected is x. All right, and then the question is, since we are saying to the right by 5 units, what does that mean? To the right means we add, but since it's saying 5 units to the right, it means we add 5 to who? To x, who is affected, right? So that means we are going to say that C, which is -2 and -2, the image of C, -2 plus 5. Okay, we add -2, we add to -2, 5, and then we get what? The image of C is going to be 3 and -2. That is basically the answer for the image of C. Okay, hope that was really meaty and straightforward, to the point. So to the right means we add, to the left means we subtract, to the left means we subtract, to the right means we add, to the left means we subtract, to the right means we add, to the left means we subtract, to the right means we add, to the left means we subtract, to the right means we add, to the left means we subtract. I'm sure someone can actually put a nice music to that. Okay, so to the left means we subtract 2x, right? And then to the right means we add 2x. Okay, right. Now let's go to number 4. D is -1 and 2, and the question is, if it's translated 1 unit up, what are the new coordinates? But before we go into that, let's try and go and obviously locate our points C and the image of C on the Cartesian plane. So -2 and -2 on our Cartesian plane. Let's go there, -2 and -2. -2 for x and -2 for y. Where we meet is exactly there. So that is basically our what? Our C. -2 and -2. Okay. Then when we have the image of C, which is what? 3 and what? And -2. So that is basically here. Okay, so that is basically our two pairs of ordered pairs there. Okay, yeah, that's what we're doing, Jenny. We are doing maths now full time. That's definitely it. Okay, then let's move on to the next question, as it says D, which is -1 and 2, 1 unit up. So D, which is -1 and 2, 1 unit up. Now when we are talking up and down, we are still speaking about translation, but up and down movement speaks to vertical translation. Vertical translation. When you go up, it means you are high up in the sky. I mean, you think about someone who has gone up in their performance in mathematics from term 1 and term 2. What is happening when you go up? When you level up, what happens? You are getting better and better, right? Your marks are getting higher. You are adding value to your mathematics performance. So anything that goes up means there's something being added. But when anything goes down, think about when you went down in your mathematics performance. When you go down, it means something is being subtracted in your performance. But now we need to think about who is affected. So two things. Vertical translation speaks to who is being affected, y is being affected. We are no longer dealing with x being affected when we talk about vertical translation. We talk about y being affected. Okay, so our y value is the one that is being affected when we talk about vertical translation. So if we are saying D -1 and 2, as number 4 states there, is translated 1 unit up, the first question we want to ask ourselves is, who is affected? Who is affected by this change? Y is affected by this change. So now it means our attention turns to the y coordinate, not to the x coordinate, but to the y coordinate. Then the question is, how is y affected? Then of course y is affected because it basically says it is translated 1 unit up. So what does that mean? It means we add 1 to who? To y, because 1 unit up means plus, we add. If we said 1 unit down, it would mean we subtract. So we go to D, we write down the coordinates, then we are going to say the change is that the image of D, when what? When the point is shifted 1 unit up. So it means we are going to go to the y coordinate, which is 2, and we are going to add 1, not to the x coordinate. X coordinate is left untouched, but the y coordinate changes. So then that means our image of D is negative 1 and 3. So that is our coordinates of D, negative 1 and what? And 3. And there it is. Okay, then we can go to our Cartesian plane. We can go and actually sketch and locate the point. Okay, so D, which is negative 1 and what? And 2. X is negative 1, y is positive 2. Where do the two meet? Mom and dad finally met in this beautiful restaurant. That's where they met. That is D, negative 1 and 2. What about the image of D? X is negative 1, y is positive 3. So D x here, y, which is 3, is there. So that's where mommy and daddy met. So we say D is the image negative 1 and 3. That's basically where D will be located. Make sense? Hopefully it does, guys. So when we're talking about vertical translation, it's either we are saying up, which means we add something, or down, which means we subtract something. Who is it affecting? It's always going to be affecting y, because vertical translation affects y. Then our next question, guys, which is number 5. Negative 1 and 3. E, which is negative 1 and negative 3, we are told is translated 4 units down. What does that mean? 4 units down means vertical translation again. 4 units down means vertical translation. So that means who is affected? If we're talking about vertical translation, it is y. So if you guys can tell me in the comment section, I'm not even going to do this one. I'm going to allow you guys to actually give me the answer in the comment section. What would be the new coordinates of E, the image of E? What would be the new coordinate if we're saying it's translated 4 units down? Yes, thank you so much. Lesejo says the image, all right, would be negative 1 and negative 7. All right, I have a feeling that you'll probably be the only one that's answering this question. Thank you so much, Lesejo. I see that. So yes, let's just confirm if that is true and authentic. We have negative 1 and negative 3. So of course, since it says since it says 4 units what down, it means we are going to do what to y? We are obviously going to affect y, but we are going to subtract 4 from y. So that means our new coordinates, let's not forget that symbol that indicates that this is the new image of E. Okay, that symbol indicates the fact that this is a changed translation of the coordinates E. So we write E, the image, all right? And then we write negative 1 and negative 7. So that's very true. Thank you so much, Lesejo, and well done on that response. Okay, I think that is the end of activity 1. All right, and therefore let's just go and sketch on the Cartesian plane as we have been asked. Let's go locate E, negative 1 and negative 3. So E, negative 1 and negative 3 on our Cartesian plane. Let's just move this a bit. E, negative 1 and negative 3. That's where we are located, guys. This is so nice to actually get this exercise of locating our points on the Cartesian plane, just to verify that we can do this. And we have no problems locating points on the Cartesian plane, because this is obviously good exercise even for our functions, because sometimes learners in grade 9 have a hard time locating points on the Cartesian plane, and it's quite sad because it affects how they do in functions and other things. Okay, then negative 1 and negative 7, we are still on the same vertical line. Negative 1 is everywhere on this vertical line, as I'd always said, because the x coordinate is the same everywhere here, guys. And then here, negative 7, that's where mommy and daddy met. So E, the image, negative 1 and negative 7. Thank you so much. There. Done. Dusted. Okay. So that's activity 1. Done. Okay, let's get into activity 2. Okay. Alright, so let's get into these questions and see if we can answer them. Hopefully you've also spent some time and looked at them. So if we look at number 1, it says write down the coordinates of each point of triangle DEF. Write down the coordinates of each point, triangle DEF. So there's triangle DEF. Okay, you can vividly see it there, triangle DEF, there it is. And it says write down the coordinates of each point of triangle DEF. So triangle DEF, if you can first write down the coordinates of D. So I'm sure you guys can see that there's 1, 2, 3, 4, 5, 6. You can see that on the y-axis. Alright, so the coordinates of D. What are the coordinates of D, guys? What are the coordinates of D, the coordinates of F, and the coordinates of E? Okay, the circle says D is 0 and 1. Very true. I agree with you wholeheartedly there. So indeed, D is 0 and 1. I agree with you. And then F. What are the coordinates of F? Okay, maybe you may not see the actual value because of the box of H there, but hopefully you should be able to make sense because of the vertical lines. It's -1, -2, and then where the F is, the X coordinate is -3 indeed, and then the Y coordinate for E is actually 5. So yes, E is -3 and 5. Very true, I agree. Then lastly, the coordinates of F. The coordinates of F, -3 and 1. Very true. -3 and 1. 100%. Okay, we good. Good. Then the next question, number 2, says translate triangle DEF 4 units to the right and 1 unit up. And then it says draw the image of triangle DEF and write down the coordinates of the new points. Okay, so we're getting quite a few instructions there. That the first thing we need to do is to do what? Translate triangle DEF 4 units to the right and 1 unit up. So we have the coordinates of D, E, and F. Okay, we have them, but the instruction is to translate. Okay, and there's 2 instructions. We are told 5 units. Okay, we need to translate 5 units to the right. So 5 units to the right, and then we are told 1 unit up. Okay, so and then we need to draw the image, okay, of triangle DF and write down the coordinates of the new point. So I think we can actually do the writing down of the new coordinates first. Then after that, we'll be able to draw the image, and then that should basically answer the question in its entirety. Okay, so hopefully we have this. Okay, so we need to first understand if we are saying 4 units to the right. Remember, what does the 4 units to the right affect? Okay, remember, right or left means horizontal translation, and this will affect our x coordinate. So that means to our x coordinate, 4 units to the right, we are going to be adding 4. Then 1 unit up, this is definitely going to be vertical translation. This affects our y coordinate, and this will also be addition to our y coordinate. So we are going to take the respective coordinates of D, E, and F, and we are going to do exactly that. 4 units to the right, then 1 unit up. So that means our image, sorry, I forgot that important point, will actually be 4 and 2. That is our new image of D. Okay, quite straightforward. Okay, but also very much dependent on our right identification of the point. Remember, if we had butchered identifying D and we had identified the incorrect coordinates, then this would have led to us getting the wrong image of D. But because we've identified the right coordinates of D first and foremost, and then 2, we are now able to apply the right translation. 4 units to the right, meaning addition to our x coordinate. 1 unit up, meaning addition of 1 to our y coordinate. Then we add our integers correctly. 0 plus 4 is 4, 1 plus 1 is 2. Our addition needs to also be on point so that we get the right image of D, which is 4 and 2. Let's apply that to E. And then let me allow you guys to actually let me know in the comment section what is the new coordinates of E if we are applying the very same translation. 4 units to the right, 1 unit up. What would be the new coordinates of E, the image of E? And then lastly, the image of F. Let me allow you guys to actually find that for me. Okay, definitely got Lesejo rolling up here. Okay, so let's just check that and verify it. We see 1 and 6 for E, so that means negative 3 plus 4, and then 5 plus 1. That means we have the image of E being 1 and 6. Very true, Lesejo, very good. And lastly, the image of F. Okay, that means we have negative 3 plus 4, and then 1 plus 1. So that means we have the image of F being 1 and 2. Okay, brilliant. Very well done. Okay, very good. Then what we need to then do is we need to go to the Cartesian plane and sketch this image onto our Cartesian plane. Okay, so I'm just going to use that same Cartesian plane that I've had up for the original questions. Okay, so let's just go and locate 4 and 2, D, which is 4 and 2. So 4, which is the x coordinate, and 2, that's going to be there. That is the image of D. Then we have 1 and 6. 1 and 6. That's where we meet here. And then lastly, 1 and 2. 1 and 2 here. So that would be F image, and then E the image, and then you would basically use your ruler, right? Please forgive me for using okay, but I hope you guys get the point. You would basically use your ruler and connect those dots so that you can ensure that you are getting. If you look at this actually, all right, this is obviously your diagram. Okay, obviously if you'd been provided with a diagram sheet, you would draw this same triangle on this diagram sheet. All right, and basically what happens is that this image does not change. Triangle DF, the new image of DF, does not change size. Okay, meaning the length of FD will be the same as FD in the original image. Okay, yeah, because remember, translations means that our image simply slides up and down. Does that make sense? So that's all that's happened. Okay, it went up by 1 unit and then it slid to the right. Okay, you know, by 4 units. That's all that happened. Okay, so hopefully that makes sense and we are able to make sense of this thing. Okay, all right, let's go to the next question. In which quadrant is triangle DEF? Now, take note, they are asking you about the triangle that you have on the sketch. In which quadrant, sorry, is triangle DEF? So hopefully we all know that a Cartesian plane, our Cartesian plane, as you see it, is divided into 4 quadrants. Okay, and hopefully we know in which quadrant is the triangle DEF in. So in the comment section, if you guys can let me know. Okay, very good. So triangle DF is definitely in quadrant 2. Okay, yeah, just for those who didn't know, right guys, this is quadrant 1 on our Cartesian plane. Okay, that's where x and y are both positive. The x coordinate, the y coordinate are both positive. This is quadrant 2. Okay, because in quadrants we count our quadrants moving in an anti-clockwise direction. This is where the x coordinate is negative and the y coordinate is positive. This is quadrant 3. And then lastly, this is quadrant 4. Okay, so yes, the diagram, triangle DF as you see it on the diagram, is in quadrant 2. Okay, then let's go to number 4. Question number 4 on the paper. In which quadrant is the image of triangle DF? So guys, I sketched the image of triangle DF and here it is, the image of triangle DF. So in which quadrant is this image located? This one. In which quadrant is this image located? Okay, so hopefully we can see where it's located. Okay, thank you so much, Pasejo. So yes, that's where it's located. Then lastly, describe the translation of figure G to the image figure H. Describe the translation of figure who? G. Guys, figure G in this diagram. There it is, figure G. We need to describe the translation of figure G to the image H. So we need to look at G and then ask ourselves the question, what happened to G in order for it to be located in the position of H? Now we should understand that if we look at G and H, we can see that these are the same. G and H have the same size and they are the same shape. So nothing has happened. There's been no change of size or change of shape. We're still speaking about the same shape. So we can clearly then conclude that there is definitely a translation that has taken place. So we are only going to describe the change of image G to H in terms of translation. And when we speak about translation, we refer to translation in terms of vertical translation, which is up and down movement by a certain number of units, or horizontal translation, which is left and right movement by a certain number of units. Okay, so what's nice is that we can actually then describe that translation. All right, we can describe it. Okay, so I see Anika is saying there, is it? And Anika is asking, so which means Anika is not sure. Anika is still trying to confirm with me as to whether her answer is correct. Okay, and the question that she is, I guess, stating, but also asking me still, is it 6 what? 6 what, guys? It's very important to speak of. Remember, when we were asked questions, we were asked to basically write the new coordinates, the image when it's moved 4 units. Okay, let's not forget to use this wording, units. We say it's units, okay, or 1 unit up. So here I'm guessing Anika is saying 6 units to the left and 2 units upwards. Well, we can check that. We can verify if that is the case. All you need to do is you need to go to G. You go to the square of G, and you go to one of the corners of G. And the corner you go to is the same corner you are going to count to in the other image. So if I go to my left top corner of G, where the coordinates there are 4 and -2. I'm hoping you guys can see when I say my top left coordinate, my top left corner of the image of G, where the coordinates are 4 and -2. Hopefully you can see that. Then that means I want to go and check what has happened for that same corner to now be the corner that I see of H, which is the top left corner. That top left corner of H has the coordinates of what? Of -4 and 0. So then the question is, what happened for one to find themselves moving from 4 and -2 all the way to -4 and 0? That is the question. Okay, yeah. So I mean, when we have the diagram, we can always count. Okay, so we'll obviously can count from 4 all the way to that -4. Now when we count moving in a horizontal direction from the corner of G, the top left corner of G, all right, if we are moving horizontally, we are going to count until the bottom left corner of H. So if we count how many units we are moving to the left, it means we are going to say 1, we arrive at 3, 2, we arrive at 2, 3, we arrive at 1, 4, we arrive at 0, 5, we arrive at -1, 6, we arrive at +2, 7, we arrive at -3, sorry, it was -2, then -3, that's 7, 8, we arrive at -4. So we have moved 8 units to the left. That's the first thing that we can clearly see there. 8 units to the left. Then we are at the bottom corner of H, on the left. That's where we are, having counted from the top corner of G at the left to the bottom corner of H to the left. So we have counted 8 units. Now we want to proceed and get to the same corner of H that we had begun in the same corner of G. So we are going to move how many units to get there, to the top? So we are moving up now, and we are going to count how many units. 1, we are getting to -1. 2, we arrive at 0. So that means 2 units upwards. So we have moved 8 units to the left, guys, and 2 units upwards. That is our description. That's how we describe the translation of this image, okay, of G to the image of H. This was looking specifically at the top left corner, to the top left corner of this part, which is very important. Okay? Okay. So 8 units to the left, 2 units upwards. So that means Lesego was 100% spot on. Anika, I hope you understand now where you may have just slightly gone off, the mark. But that obviously now I'm sure is clarified and you are clear. Okay, so hopefully there's clarity now. Okay, I don't know if there's any questions, any pressing questions that anyone has right now with regards to description of transformation or description of translation. Are we good? Can I move on? Okay, that was a nice translation question, don't you think? Don't you guys think that was a nice translation question? Okay. Okay, so now we have activity 3 that we need to go to now here on the screen. Can you see? So in the figure below, reflect the point A and a triangle DEF in the y-axis. In the figure below, reflect the point A and triangle DEF in the what? In the y-axis. Now, in my video that I did, or my live lesson I did yesterday, I explained what reflection in the y-axis means. Okay, I explained it, and I think I did a pretty good job explaining reflection in the y-axis. Right, and I would really encourage those who did not get the chance to go and check out that video. I think it's very good in explaining. I think I explained those concepts quite well, unpacking the concepts quite well. Right, so just a reminder then that reflection in the y-axis simply means that we are producing a mirror image along the line x is equal to 0. So the y-axis is our vertical y-axis on the Cartesian plane. It has this equation, right? And whenever we are reflecting in the y-axis, I'm sorry about the noise. Sorry about that, guys. So reflection, guys, in the y-axis simply means that the coordinate that gets affected when you are reflecting in the y-axis, okay, is the x-coordinate. What happens to it is that it simply changes sign. So whenever we are reflecting in the y-axis, all we simply take into consideration is just a simple change in the x-coordinate. It simply changes its sign. Okay, so there's a change of sign of the x-coordinate. So if you are reflecting in the y-axis, or sometimes they say reflection in the line, along the line, x is equal to 0. The line x is equal to 0, guys, is the y-axis. Okay, so don't get confused or get lost the minute they say reflection along the line x is equal to 0. They are just saying reflection in the what? In the y-axis. And what you then need to understand is that when you apply reflection in the y-axis, all you simply do is you take the original point, you change the x-coordinate of that original point to a different sign, but then the y-coordinate stays the same. Okay, that's all that reflection in the y-axis means. Whilst we are still at it, we can look at reflection in the x-axis. Remember, the x-axis is the line y is equal to 0. So with reflection in the x-axis, that simply means in the original coordinate, all we simply do is we change the sign of the y coordinate, okay, whilst the x stays the same. Okay, that's all. So please, guys, reflection in the y-axis, as specifically as it refers to this question that we are looking at, means simply that. So let's go and check. It says in the figure below, reflect the point A and triangle DF in the what? In the y-axis. So we are being instructed to actually reflect in the y-axis where this points are concerned. So let's go first and write down the coordinates of A, because we don't know what the coordinates of A are. So guys, what are the coordinates of A? Maybe you guys can let me know in the comment section. We need to first identify the coordinates of A, and then we need to identify the coordinates of D, E, and F in the on the Cartesian plane from the diagram. So what are the coordinates of A? Because after we are done with that, we can only answer the questions that relate by first having identified the coordinates properly from the diagram. So what are the coordinates of A, guys? In the diagram. Okay, so A is -2 and 2. Hopefully we can see that. D is 2 and 0. E is 0 and -4. And then lastly, F is 5 and -2. So these are our coordinates for the respective points. Then in the figure below, reflect the point A and triangle DEF in the y-axis. Draw the reflections of the point A and triangle DEF and write down the coordinates of the reflection. That's what they want us to do. Okay, draw the reflections of the point A and triangle DEF and write down the coordinates of the reflection. Okay, so let us go and do that. First and foremost, let us check how these points, because after we have done so, we need to actually use the Cartesian plane and indicate those on our Cartesian plane. So what did they say here? These points are what? They are reflecting on in the y-axis. So we need to draw the reflections of the points and write down the coordinates. But before we draw the reflections, guys, what do we need to first do before we draw the reflections? Thank you for the Rose account not found, whoever you are. So remember, what did we say? Reflection in the y-axis. What does that mean? It means that grade 9s, grade 8s, it means that if we have a point, then the way that that point changes, if we are reflecting in the y-axis, is that the x-coordinate simply changes sign whilst the y-coordinate stays the same. Okay, because we are reflecting along which axis? We are reflecting along the x-axis, and I'm sure you guys know if we are reflecting along this x-axis, what happens? It simply means that our x value, if it was negative, it will change. Now the x value will be positive. Or if the x value was positive, it will simply change. It will now be negative because we are reflected along the what? The y-axis. That's why we say there's a change in the x-coordinates, but the y value will stay the what? The same. So reflection, the new image of A, x is -2. What happens to him? He is affected. Why? Because we are reflecting in the y-axis. X is affected. How is he affected? Sign change from -2 to what? To +2. The y-coordinate simply stays the same. D, the image. What happens to x? He changes. He becomes -2. What happens to x? He simply does what? He stays the same. What happens to x? X changes sign, but 0 is a neutral number, guys. So since 0 is a neutral number, 0 is neither negative or positive. So saying that it will change, in actual fact, 0 will basically remain neutral, but the y value stays the same. So we can say that in actual fact, the image, of E is actually staying the same, even though it is being reflected along the what? The y-axis, which makes sense. Then F, the image of F, 5 is positive. Obviously now it's going to be negative. And then obviously the -2 does what? It stays the same. So now we can actually go and let's just draw a Cartesian plane here. Okay, so this is 0, sorry. Okay. So I'm sorry, this is freehand, but I know you guys would actually use proper, stuff to make sure that your Cartesian plane is not, 1, 2, 3, 4, 5, 6, 7. And then the side, obviously, -1, -2, -3, -4, -5, -6, and -7. Okay. Alright, I know this is kind of like slightly off scale because this is all drawn freehand, but of course, if I was drawing this nicely and I was not holding my phone with the other hand, I would definitely make sure that the same space from 0 to 1 is the same space from 0 to 1, so that my diagram is actually properly indicated. So now I can actually go, and it says I need to actually make sure I indicate these points on my Cartesian plane. So the image of A, 2 and 2. So let's first write down the originals that were there, -2 and 2. We know that the diagram has already provided the diagram, the points there on the Cartesian plane. But -2 and 2. So -2 of x is there, +2 of y is there, where the 2 points meet is there. This is A. Then the image of A, which is 2 and 2. A, which is +2, is there. Then xy, which is +2, is here. That's the image. Okay. Then D, 2 and 0. D, which is 2, and y, which is 0. We are still here. Okay. E, 0 and -4. So E, which is 0, x, which is equal to 0, is everywhere on this vertical line, the y-axis. Negative 4 of y is here everywhere on this vertical line. They meet there. And then lastly, f, which is 5 and negative 2. X, which is 5, and then y, which is negative 2. That's here. We are located there. Okay, right? And this is where the triangle is situated. Triangle what? Triangle DEF. All right, now let's go now and write down the image of DEF, okay, reflected along the y-axis. So D, negative 2 and 0. So negative 2 and 0, we are here. 0 and negative 4, where x is 0, y is negative 4. We are still at the same point. Then lastly, negative 5 and negative 2, where x is negative 5, we are here. Then y is negative 2, we are there. Where are we meeting? We are meeting here. Mommy and daddy met there. Then we basically connect these points. That is our triangle. All right. Yeah. Huh? Two triangles, right? And obviously this one seems slightly bigger because, sorry guys, if I had drawn my Cartesian plane equally spaced, you see, because this gap here is, this one is bigger than this one. Okay, these should be exactly similar because remember, reflection does not change the shape and the size of the triangle. This should actually be exactly the same size. Okay, and I'm very sorry that you do not see that, but this is the reflection along. So this is a mirror image of that along this y-axis. This is a typical example of reflection. This here also is a reflection of the two. That's why this is A and A, the image reflected along this y-axis. So this is a typical diagrammatic representation of reflection along the y-axis. So that's it, guys. I hope you guys see, okay, the relevance. So this would be F image, E image, and obviously D, the image of the original triangle. Okay, cool. I hope we cool, guys. I hope we cool. I hope we good. Right, I don't know if there's any questions that are pressing. You can use the comment section for the purpose of asking questions if there are any burning hearty questions that anyone has with regards to what I've just done here. Okay, but yeah, that was just me answering that first question in activity 3. Draw the reflections of the point A and triangle DF and write down the coordinates of the reflections, you know, and there are the two diagrams, the original triangle DF with its reflected form, and these are the coordinates that I basically got from the reflections. Okay, A image, D image, E image, and F image reflected along or in the y-axis, because with reflection in the y-axis we know that there's simply a change in the sign of the x-coordinate whilst the y-coordinate remains or stays the same. Okay, now the question that follows after A is B under activity 3, which says which coordinates stay the same. Okay, so I'm sure guys you saw the coordinates that stays the same here. I'm sure you saw the coordinates that stay the same. We can clearly see that E and the image of E stay the same. We saw that. Okay, why was that the case? It's because if we are reflecting along the y-axis and x coordinate is 0, remember 0 is neutral, so 0 remains unaffected, if you will. All right, yeah, so that's why basically we say that this here stays the same. So the question was B, which coordinates stay the same after the reflection? So I would say the coordinates of E stay the same. Okay, the coordinates of E and its image Yeah, and they are basically both 0 and -4. Yeah, so I hope that makes sense. Even after reflection, no change, no change. All right. Okay. Then which coordinates changed after the reflection? Then of course, which coordinates changed after the reflection? We have A, we have D, we have F. They all changed. All right. You can see most the x coordinate changed, whilst y stays the same. X coordinate change whilst y stays the same. The x coordinate change whilst y stays the same, because that speaks to a reflection in the y-axis, or the line x is equal to 0, because the line x is equal to 0 is the y-axis. Okay, I don't know if there's any other pressing questions or any other clarity that people want or are seeking. Okay, all right, let's move on to the next question here. In which quadrant is the reflection? Okay, I'm going to leave that to you guys. And then number E, did the shape or size of the figure change? Let's answer those questions. In which quadrant is the reflection? Okay, remember this was the original. All right, so I think they are asking specifically. Okay, so remember guys, this was the original, and then this is the image. Okay, so now the question that is being asked. Okay, I think we can answer questions independently here. Firstly, we can answer for the triangle. In which quadrant is the reflection? Okay, let's look at triangle DF. Triangle DF originally was in the 4th quadrant, but then after the reflection, which quadrant is triangle DF now located? After the reflection. Okay, so the image now is in the 3rd quadrant. Okay, yeah, so that is for the triangle DF. But if we look at A was originally in which quadrant? And now the image of A, in which quadrant is it? Okay, yeah, so in which quadrant was A, the point, located? And then the image of A now, where is it located? All right, so these are important questions that if we can answer well those questions, then of course, you know, we are actually closing in on making sure that we are covered where, as far as the concepts of transformation geometry are concerned. So there is A, and then the image of A, where is it now? So A was in the second quadrant, okay, but now it is in the first, okay. So if you were doing a description answering of this question, you would have to actually break it down as such. Describe the change in quadrant of this image, and then describe the change in quadrant of that image, so that there's clarity as to what you are doing and what you're answering. Then E says, did the shape or the size of the figure change? Did the shape or the size of the figure change? Okay, so if we look at this original, guys, okay, remembering what I've also said earlier on, does the shape or the size of the figure change with reflection? Okay, will the size, yeah, the shape or the size of the figure change? Okay, definitely no. Okay. It's a definite no. So there's no change. Okay. All right, let's look at question 4, activity 4 actually. So now we are looking at, it says in the figure below, reflect the points D and E and triangle ABC in the line y is equal to x. Okay, so once again, I'm going to pull out our notes, and when we're talking about reflection, specifically in the line y is equal to x, what does that mean? It basically means that the x and the y coordinate of the original point are simply swapped so that you can get the image of the original point. So we swap x and y, and that's it. X becomes y, y becomes x. So that is basically what you are seeing here. Alright? Yeah, that's a reflection in the line y is equal to x. Alright? Swap or change. Guys, if you want to get in more into what I basically did with, because I explained all of this in my live lesson yesterday, you guys can check out the video I had posted yesterday on the live lesson on transformation geometry with regards to this, and you can get into that. Okay, so A says draw the reflections of point D and E and write down the coordinates of the reflections. Now it says in activity 4 1.1 at the top, before you even look at the diagram, in the figure below, reflect the points D and E and triangle ABC in the line y is equal to x. Now if you're saying in the line y is equal to x, it means you are talking about the reflection in the line y is equal to x. Alright, and we had just now explained what does a reflection in the line y is equal to x actually mean. Okay, so I'm sure you can see in the diagram that there's a diagonal line that's cutting through the origin, and then it's labeled there at the top right corner of the Cartesian plane as the equation y is equal to x. That would be the straight line y is equal to x. So that means everything that is being reflected will be reflected along that line. And when we talk about reflection along that line, it simply means that we are going to actually do what to the image of the respective points. To the original point, we are going to do what? We are going to swap around the x and the y coordinate. So the first question there, A, says draw the reflections of points D and E and triangle ABC and write down the coordinates of the reflections. Okay, now guys, I would actually answer these questions for you, but I won't. Okay, I think I'm going to stop right here, and I'm going to allow you guys, you can screenshot if you want and get an opportunity to answer these questions on your own. Okay, right, and if there are things that you get lost about as far as the questions are concerned, you are more than welcome to go and check out some of those things on my YouTube, like I said, because I have explained these concepts and did examples. So for now and today, I'm gonna hold it right here. Thank you so much for joining the live lesson. I hope you learnt a lot, you enjoyed it, picked up something there and there, and I will see you tomorrow. Yeah, and I'll actually pick it up from here. We'll answer these questions, finish off activity 4, and then yeah, hopefully then we can get into area, perimeter, surface area, and volume, which are basically the last few topics for term 4, and that will basically be it. And then as from when the term opens, I'll only be doing exam papers, guys, preparing for the final end of year exams, GEC, the works, and just final end of year exam papers. I'll be doing a lot of those live lessons on exam papers. We will just be answering exam paper after exam paper after exam paper after exam paper, so that we can get familiar with the style of questions being asked in exams and also become a bit more fluent in answering exam type questions. But thank you so much for joining in, those who joined, and please have yourself a great day. I will be uploading the live lesson, the recording of it, onto my YouTube channel the minute I'm done. First have to obviously download it and then upload it.